a little different in terms of its range restriction. The arc cosine did its range restriction 0 to 180. That's not going to work for an arc sine. For this range, I need a range of angles that covers every possible y value exactly once. So I need to go from -1 on the y-axis to 1 on the y-axis without repeating anything. If I tried to use the same range from arc cosine, I would only get positive y values, I would never get negative y values, and I would also repeat all of those positive y values twice. Like here. Pi over 4 is giving me the same y value on the unit circle as 3 pi over 4. They both give me root 2 over 2 as a y value. So this isn't going to work. This range restriction on arc sine will not do the job. What I need is something that covers this range of y values. Using the first quadrant is pretty intuitive to get all your positive y values. I don't want to leave these out. These are like your most basic angles. This is your 0 to 90 degree angles. These are all the things that you find in right triangles. They're pretty important, so I definitely want to include them. But I also need to include these negative values down here. I don't want it to be disjoint from this other piece. So I don't want to have to be 0 to 90 or 180 to 270. So I'm not going to use the third quadrant angles. I want it to be one continuous piece that's connected to this. So I'm going to finish that and go down here to get my negatives. And here's where this is going to get a tiny bit awkward. I want this to be one continuous segment. So I don't want this to be 0 to 90 or 270 to 360. I want this to be one continuous chunk of angle. So I'm going to say that it goes from negative pi over 2 to positive pi over 2. That way it's all in one range, not two separate disjointed ranges based on whether the answer, the input is positive or negative. We're going from negative 90 degrees through 0 up to positive 90 degrees. So, quadrants 1 and 4 are the range here, but the quadrant 4 angles are negative. If we're doing a quiz, and I ask you for the arc sine of negative root 3 over 2, if you tell me that the answer to this is 5 pi over 3, I'm not going to give you points for that question on the quiz. Negative 5 pi over 3 is not in the range of arc sine. Range of arc sine only gives you numbers between negative pi over 2 and pi over 2. So this is no good. The answer you need to put here is negative pi over 3. This is your y value. You need to get there down here, negative angles. You can't get there over here. This is no good. This is where you need to be. So that's the range on arc sine. Arc tangents, we'll use the same range. Let me write that somewhere. I'm done with exposition. Done with exposition. Time to recap and summarize. Arc sine of x takes in y values on the unit circle and returns angles between negative pi over 2 and pi over 2. Arctan of x takes in, I'll stop using x's. I'm going to use a number symbol. Arcsine of a number takes in y values on the unit circle and returns angles between here. This arctan takes in x over y over x ratios on the unit circle and returns angles in the same range as arcsine. Both the arcsine and the arctangent use angles in this range. Arccosine is the weird one, or maybe it's the normal one and these two are weird. Arccosine of x takes in, no, let me keep using numbers. Arccosine of a number takes on an x value on the unit circle and returns an angle between 0 and pi. Hopefully that's readable down there at the bottom. Looks good. Yeah. So these are the range restrictions on arcsine, arctangent, and arccosine. I mentioned briefly that we needed to talk about domain restrictions as well, and I feel like the domain restrictions here should be relatively clear from this information. If the number you put into an arcsine needs to be a y value on the unit circle, that means it has to be between -1 and 1. 2 is not a y value that appears on your unit circle. Your unit circle has a radius of 1, that's why it's called a unit circle. So you can't get 2's, or you can't put 2's into here, just like a sine function will never give you a 2 as an output, and arcsine can never take in a 2 as an input. Same with arccosine. These x values have to be between -1 and 1. They can be inclusive though. So -1 to 1 is the domain here. -1 to 1 is the domain here. -pi over 2 to pi over 2 is the range here. 0 to pi is the range here. Arctangent does not have range restrictions. You can take the arctangent of any ratio you like. That's all for this video. Stay tuned for talk of section 6.5, where we take these ideas and do more strange things with them in the form of equations.